Yes, sir.
Now, chain rule is one of the methods that we use in the differential calculus to work out the derivatives of the given functions. Now, your question should be, why chain rule? We have chain rule because the other methods available, that is the power rule and the quotient rule, prove to be insufficient. You know, there are some complex, form of functions that may not really be done using the power rule and the quotient rule. So what you need to do then, you have to introduce the other concept, and that is the chain rule. You should know how to work with the chain rule. So, yes, for example, the quotient rule, I said, is used for functions that are dividing each other. You have the functions that are dividing, let's say you have 2x squared plus 4x to be divided by maybe 3x cubed plus 3x plus 5. You have rational functions. In that case, then you employ the quotient rule. And the way the quotient, we know that this is basically an answer that you find after dividing numbers and expressions, right? Your mathematical expressions, for that matter. You have the quotient rule. Then now, what if you have this situation where you're dealing with numbers, maybe under radians, that are held to the degree higher than 1. Remember, the power rule is easy to work with when you're dealing with numbers raised to the power 1. They're linear when you have the linear function. What if now when you have radians like this, let's say you have radians like this raised to the power, let's say 2x plus 3. In that case, you cannot use the power rule from here. Okay? You can't use the power rule from here because we know that when we write this function, it will be 2x plus 3 using the rule of indices raised to the power half, yeah?
Yes, sir.
This is the, the similar expression. And when you have such an expression, you may not manage to apply the power rule here. So you invite chain rule to help you to work out this particular derivative. Okay, so as long as you have such, you could have another one. I'm just introducing you to chain rule so that you know when to use it. You should know when you look at the function that here now, definitely we need the chain rule. What if you have a number like this? You have the fifth root like this, okay? And maybe it has also a 2 here. Remember, I was explaining things like this. Then you have 3x plus maybe 4x squared. How do you work out this? You know that this shall be same as raising this number as 3x to the power plus 4x raised to the second degree to the power 2 over 5, right?
5, yes, sir.
You remember? Now, when you're dealing with such expressions, you can't use power. Power rule fails. Yeah. And again, you can't use quotient rule, because these are not rational functions. Okay? So when do you actually use power rule then? You use power rule, when do you use chain rule? You use the chain rule when you have the radicals like this, and the, functions that in the roots. And also you have functions that are in the parentheses. These we don't call them brackets, they are parentheses. Raised to the power. When this is raised to the power 1, you can use power. But as long as the power is not equal to 1, these brackets or parentheses of yours, they are raised to the degree that is not equal to 1. Get it, right? Not equal to 1. It can be a fraction, meaning less than 1, or it can be any number higher than 1. Please, you apply the chain rule. Any questions?
I'm following.
Could ask us questions if at all there are any questions. We want to clarify this point and just make sure everything is fine with us.
Noted. Yeah.
If you do not have questions there, from here we can proceed and invite to the conversation examples. So when you are working with the chain ruling, we have the function of the form. Let's say the function is y equal to, fu. This is a function of u, right? The function is the y is a function of u. In that case, then how we work using the chain rule to find the y over the x, meaning the derivative of this function, number 1, you have to split the function. Okay, the function that is inside the parentheses like this shall be your u. You're following, right? It will be function u. And then that u function, you replace into the y function. So the y function will be equal to u now again. It will be different. Yes, because where there is a function, you replace by putting u. And then you solve for the 2 derivatives. You differentiate this y equal to u and find the dy over du. You know that dy over du simply means you are differentiating the y function with respect to u, right? That's why dy du.
Yes.
And then you will also have another function, du dx, meaning you are differentiating this u function with respect to x. That's simple. So you multiply the 2 derivatives. And examples can always do better. Let's have an example here and find it. So we have the root, of 3x squared plus 4x. This is the function that we have. And we have to work out this particular function and y is equal to that. And I told you that from here, the easiest way of doing it is to do what? Is to rewrite this function. Yes.
Yeah.
We shall have y equal to 3x raised to the 2nd degree plus 4x raised to the power 1 over 2. Now we have the function we read. And then we shall have the 2 parts of the functions. Number 1, the inner function shall be your u function. So your u function is equal to 3x raised to the 2nd degree plus 4x. Yeah?
Yes, sir.
And the y function, therefore, shall be where there is this function you replace by putting u. So it will be u to the power half.
Yes, sir.
You agree now we have 2 functions, right? Then to find the dy over the x, we know that we shall have a dy over du first, meaning you are differentiating the y function with respect to u, multiplied by the du over the x, meaning you're differentiating the u function with respect to x, and multiply the 2 derivatives. Then that is how you find the chain rule. Yeah?
Yes, sir.
So from here now we can proceed and we have the y du. Let's have the y function. This is raised to the power half. You drop the power, you know the message now. Dy over du shall be equal to drop the power, that will be half u to the power negative half. Right? Isn't it? Because we have deducted 1, so the half minus 1 is negative half. Okay?
Yes.
Of which you could still rewrite this function. You could say 1 over 2. Then this part, you could rewrite it and put it under parentheses, right? When you put it down, now So you have to explain step by step so that people don't point fingers at you. So this is how it is done. You could have half multiplied by u. You're following this? So we could rewrite this one. This is it as negative. We can have 1 over u to the power half. You agree that this is equal to this part, right? Using the rule of indices. Right?
Yes, I'm getting it, sir.
So if we have managed to do that, then we can easily multiply and have 1 times 1, 1, 2, u to the power half, which is same as what? It is same as saying 1 all over 2 to the root u, right? It's the same thing. You agree with me, right?
Yes, sir.
Is there any question?
For now, no, because I'm saying I think we did something like this the last time we ended.
Yeah, in the tests. Yeah.
Yes. Yes.
So, but that time I wasn't teaching. Now I am teaching.
Okay.
Now let's find du dx.
Okay.
We have found the dy over dx to be equal to that. Now let's find the du of dx. Du over dx, we're differentiating the u function, right? We are differentiating this u function with respect to x. So it shall be 6x, right, plus 4, isn't it? Do I have to explain the power rule again? Drop the power, start.
No.
Yeah. So that's the derivative for us. And then now we have the du over dx. So our formula is dy over dx equals to dy over du to multiply with du over dx. So that is the dy over du is 1 over 2 the root of u, right? Multiplied by, yeah, du over the x is 6x plus 4, right? We can put over 1 here. You agree with me, huh?
Yes, sir.
Are we good? Yeah.
Yes, sir.
So from here, you could easily work it out. 1 times the numerator will have the same numerator, 6x plus 4, all over 2 the root of u. Is that clear? I've just multiplied that times that, numerator to the numerator, denominator to the denominator. And then when we reach here, it becomes very easy. We know what u is, isn't it? We can easily just replace now. Now that we know what u is, we can replace u. And we shall have 2 root of, what is our u? Our u is 3x squared plus 4x, isn't it? Right?
Yes, sir.
Any question? This is the derivative.
Oh. No, it's clear. It's understood.
Yeah, so it grows. Imafufumuka, it grows. Yeah.
Okay.
That is. This is the way how to deal with it. If you don't want to start dividing or whatever those things, saying this is u, this is y function, the other way of doing it is y is equal to the root of 3x squared plus 4x, yeah? Now, listen to the other way of doing it. We could rewrite it, y and say 3x squared plus 4x to the power half. Now, when you get here, the rule is you drop the power. Look at this. Drop the power half multiplied by the way how this same stuff is. Maintain the way how it is, right? Don't change. That will be 3x squared plus 4x to the power negative half, right?
Yes.
You've seen what you're doing. I've maintained this. Treated it as a single coefficient. And then from here, we differentiate the inside function. Whatever we had maintained, we differentiate it. It shall be 6x plus 4, right? You have followed the steps?
Yes, I'm following. Yes, sir.
So drop the power and reduce it, maintain what is inside, then differentiate the inside function. And then from here, it becomes very easy. You just need to rewrite.
Yeah.
We know that we can rewrite this as 1 over 2 multiplied by, since this is to the power half, 3x squared plus 4x to the power half now, not negative half, because 1 has gone on top, right?
Yes.
Multiplied by 6x plus 4.
Okay.
And then from here, we shall have 6x plus 4 to be divided by 2 and the root of 3x squared plus 4x. It's the same thing. Right? Differentiate, keep the inside function the way how it is. And then you differentiate the inside function and you multiply the two.
Okay.
I guess this is what they use here. So this is the approach that they use here. Any questions, Ben? There are no questions.
No, it's
quite easy stuff.
Clear. Yeah, it's clear.
Oh, that's nice. So that's a bit about the chain rule. I talked about the product rule, yeah? I remember talking about the product rule. I talked about the quotient rule and the power rule. Then now we can go at the applied level of these. The application of differential calculus in economics is used to find what we call the marginal functions. Okay? We find what we call the marginal functions. So the marginal cost, for example, you want to find the marginal cost function, which expresses the change in the total cost function, right? Or is expressing as the change in the actual cost of producing an additional unit. And the marginal cost shall be found by differentiating the total cost function. So you have the total cost function, differentiate the total cost function with respect to output, you will find the marginal cost function. Is that clear? Differentiating is not a problem now. You know how to differentiate using different formulas and different methods, right?
Yes, sir.
And again, we also have what you call marginal average cost function, which means it's marginal average cost. We need to find the average cost function, then marginalize it, meaning differentiate it. And we know that the average cost function is found by saying total cost function, fixed cost plus variable cost, that's total cost function, divided by output. This gives us average cost, yeah? Average cost is total cost divided by output, yeah? And then when you find this, you differentiate the average function, the average cost function. then you will have marginal average cost function. Is that clear?
Yes, it's clear, sir.
The marginal revenue function is coming from total revenue function. Given the total revenue function, which is found by saying price times output, then you got to differentiate the total revenue function to find the marginal revenue function. It measures the rate of change of the revenue function, or rather approximating the revenue from the sales of an additional unit. When you sell an additional unit, your profit does increase, yeah? Revenue increases. So that is what the marginal revenue function does measure. And it is found like that. Differentiate the total revenue function. Marginal profit function, obviously, you could guess it is about differentiating the total cost function, the total profit function, marginal profit function. And the profit is found as follows. It is actually total revenue minus total cost. That's how you find the profit. Whereas total revenue is price times output, right? And you differentiate the total cost function. You have the total cost function deducted from that. You have the profit, and from this profit, you could differentiate the total profit function to have the marginal revenue function, or the marginal profit function, yeah. So basically, this is the message that we were sending across. I think it must be able to be fine and sit well with us. Now, the other thing that we have is the concept of elasticity of demand. Now, when we're talking about elasticity of demand, we could apply a calculus here again, and to the specific differential calculus as you are trying to find the elasticities of demand. And by definition, we say elasticities of demand simply means, you know, the responsiveness is the responsiveness of the quantity demanded to the change in any of the factors affecting demand. Wow, this is interesting. I am saying that the quantity demanded does respond, right? Whenever any of the factors affecting demand changes. For example, if it is on price, meaning the price of the commodity changes, then you will have the on price elasticity of demand, right? You'll have the on price elasticity of demand when that happens. If the change has been necessitated by the on price change, or the change in the price of the on commodity. Okay? Hello?
Yes, sir, I'm getting you.
And then you also have income. Income could change, right? Those are factors affecting demand. Income could change and affect demand. Now, if you have income changing and affecting demand, then you shall have what you call the income elasticity of demand.
Yeah.
That will be income elasticity of demand. You could also have the prices of other related goods, such as the substitute and complementary goods. Substitute goods and its complementary goods. If the prices of these related goods change and then have managed to influence the quantities demanded of the commodity in question, and then at that point we shall have what we call cross price elasticity of demand, isn't it?
Yes, sir.
Yeah, so in a nutshell, this is what we wanted to just remind from microeconomics. Now, how do we apply calculus and differential calculus? Now, could you assume that you have a function and the demand function is given as this, is a function with respect to price, right? It's a function that has a price function. This is basically the demand function. It has price inside, right? So now, then you can calculate the elasticity of demand of this particular function by differentiating the function with respect to P. I have not heard. I repeat, if you have a demand function, let's say your demand function is this quantity demanded, and then the function is equal to, maybe the demand function is equal to 5 plus a 2p. This is the price. And these are linear functions. They are not a non-linear functions like quadratic above. So it means the power shall always be raised to power 1 price. I'll repeat. These will be linear functions. So the power of price shall not be greater than 1 or less than 1.
Oh,
so,
okay.
Yes, this is the message we're sending. So elasticity of price, elasticity of demand, this is called the on-price elasticity of demand, shall be found by the following, right? It shall be the price prime, right? That is to say, you get the derivative, right, of the function, okay? It will be price times the derivative. F prime is the derivative of this function. The demand function has been differentiated with respect to P, right? You're following what we mean? I'll repeat that. The price multiplies by the derivative of the function with respect to price, meaning you have differentiated this function with respect to price. Okay? And then
yes, sir,
this function is differentiated by the on function itself. So this will give us the elasticity of demand. Now, if you find that the elasticity is greater than, if it is greater than 1, the interpretation is that the demand is elastic. So when you say that the demand is elastic, the message you are communicating or sending is that the quantity demanded responds, to a greater extent to any changes in the on price of the commodity. That is to say, when the commodity changes, the price of the commodity changes impacts the quantities demanded, yeah? The quantity is demanded.
yes, yes.
And if that is the case, all right, if that is the case, then what usually happens is that the demand of the function that you are seeing, the elasticity thereof shall be elastic. That simply means when price changes, the response that you see is greater. That is to say, if prices changes maybe by 20%, then the quantities will respond by an amount greater than 20%. That will be maybe 40% reduction in the quantities demand. You get what we mean, eh? When prices have increased just by 20%, but the quantities will reduce by more than 20%. That is what we mean by elastic.
Yeah.
But if you say it is unitary, then it means they're equal. That is to say, if price changes by 50%, also the quantity will just change by 50%, responding to the changes in price. Now, in elastic, is the other way around. That is to say, even if price, is changed by, let's say, 25%, then the quantity changes by less than 25%, maybe just by 10%. That is to say, the quantities demanded don't respond so much to price changes. That is inelastic.
No.
You got it, right?
Yes, sir.
I repeat again what I was saying. Now it right. I'm saying that if the demand is elastic at P, then an increase in unit price causes a decrease in revenue. So revenue does decrease, and a decrease in unit price causes an increase in revenue. That is the meaning. So you have to pick the message here. The message is that when the demand is elastic, what happens to revenue? Then if the price increases, then revenue decreases. That is if the elasticity is elastic, yeah? But if the price is reduced at that point, then revenue shall increase. That is for elastic. Right? That's the economical interpretation that you should take home. If the demand is unitary, meaning equal, then an increase in unit price, right? The revenue will stay about the same. There will be no change in revenue. If the demand is inelastic, then an increase in unit price causes an increase in revenue. This is the message. When it is inelastic, just know that you increase the price, also revenue increase. I think it should make sense, yeah? Because it means that even if you increase the price, people are not responding. They're not going to reduce the quantities. So revenue will increase as we keep on increasing price. Yeah. And a decrease in unit price causes a decrease in revenue. Sure. And now an example will do it better for us. Consider the demand function or the demand equation given here. It is given as an inverse demand function. Price is equal to negative 0.02x plus 400. This is the inverse demand function, right? It is just there to describe the relationship between the price and the quantity demanded. And the quantity demanded is represented as X in this case. So you are to find the elasticity of demand. Now, how do you find elasticity of demand? Remember from the formula, we said that you have to express this function first and make sure that it is a function of P. Price should be not the subject of the formula. So you got to invert this function again. This is an inverse demand function. Make it a normal demand function. So make X the subject of the formula. That's the message we are sending. Make X the subject of the formula so that P can go the other side. You have heard the reason why we are making it like that, so that the function can be a function of P, price. And so we shall have we will have the function given here. Let's collect the like terms together. We shall have 0.02x. That should be equal to 400 minus P, isn't it?
Yes, sir.
And we can divide through by 0.02, yeah? Everywhere. 0.02 by 0.02. So that the X can be equal to 0.02 into 400 gives us 20,000. You can just take that. And then 0.02 into 1, there is a visible 1 here. That gives us 50. So have negative 50p, like that. This is now the function inverted. Okay, we could go now ahead and find elasticity. And how do we find elasticity? The message is that this is the formula that we say use. So we need to derive this function with respect to what? To price. Yeah. Right? And divide the function by the inner function. This price should be there. The derivative. Okay. It is price times the derivative. So now, at that point, what we will have is, let's derive this function with respect to P. It will just be negative 50, right? Because P is raised to the power 1.
Yeah.
This is what we mean by F prime P is 50 multiplied by this P. You get what I mean, eh?
Yes.
Times P. That's the numerator. Divided by the original function, which is negative 50 P plus C, 200, 2000. And from here, we could easily simplify the equation, yeah?
Yes, sir.
Could simplify the equation. And how do you go about simplifying all this? How could we go about simplifying all this? 50s will cancel, yeah?
Yeah, the 50s will cancel. Then P
will cancel.
P will also cancel. So we'll have 1 divided by 20,000.
Okay, let's factorize in the denominator, negative 50p divided by what is a common factor? It is 50, right? 50 is a common factor. Yeah, so you remain with the negative p, right? You're following, right?
Yes.
Negative p plus 50 to 20,000 goes 400 times. You've seen that? And so this and that will go, right? You're following, eh? So have negative p over 400 minus p, right? You're following, eh?
Yes,
then times this negative in the formula. You've seen the negative in the formula. See here. So it will multiply with so it will be times negative 1. So that will make it P now, positive P. That's where that positive P is coming from that you're seeing in the question.
Okay.
Now, there's another question. A monthly demand for t-shirt is given by that, where P denotes the wholesale unit price and X denotes the quantity demanded. And then the monthly total cost function is given here. This is a cost, this is a price function. Find the revenue and the profit. Find the revenue. How do you find the revenue? So we say the revenue is equal to what? Price times the quantity. And our quantity is denoted by X, isn't it? You're following? We don't have to lose you. This is applied mathematics. Now you get to follow here.
I'm following, sir. I'm just muting because the babies are around so that they don't disturb your sound. The sound. Yes.
And so you shall have negative 0.05 x plus 25 multiplied by the quantity which is represented by x. And so you can FOIL from here or expand to have the total revenue equal to negative 0.05 x squared plus 25x, right? This is the total revenue function, isn't it? Yeah?
Yes, sir.
And we already have the total cost function. Then they have asked us to find the profit function. We know how we find the profit function. How do you find profit function? It is total revenue minus total cost, yeah? That's how we find profit. Total revenue function is already here with us. I guess you're following. You can see the total revenue function, we have found it. It's negative 0.05 x raised to the second degree plus 25x. Right? Minus, are you following now? We have costs function negative 0.001 x squared plus 2x, right? Plus 200. Isn't it?
Yes,
that
sir.
is. Then we could go ahead and now expand the function. Negative 0.05x to the power 2 plus 25x plus 0.001 x to the power 2 plus 2x. Can we say plus now? No. We are expanding times negative.
So it's minus 2y.
Minus 2x, it is x, minus 200. Right. Profit function. And then we can easily, work out these functions. We group the like terms together. You shall have negative 0.05 x squared plus 0.001 x squared plus 2x minus 2x minus 200. This will give us 0, yeah? What is negative 0.05 plus 0.01? In short, what is 0.05 minus 0.001?
Let me give like one. Hello?
Yeah.
Oh, the screen has gone.
You can see it.
Okay, now I can see. Okay, let's do this. It's negative, right?
Mm-hmm.
Negative 0.05 plus
0.01 x squared.
1. You can't add this. Oh, the x. Okay. So it's negative 0.049.
0.049 x squared minus 200 as the profit function, right?
Yes.
This is your profit function. And then the second question was asking us to find what?
Find the marginal cost, marginal revenue, and marginal profit function.
I think we can start with marginal profit since we have the profit function before you erase it. You differentiate this function. Drop the power, so just multiply this times 2. 0.049 times 2.
Yeah. 0.049 times 2. Negative 0.092.
92.
Yeah.
X, like that. Because 200 is a constant. This is the marginal profit function. Okay? Let's find the marginal cost function. The marginal cost function is this same one. Just multiply this by 2. Let's do the marginal costs. We'll come back to marginal revenue. Okay. Let's do marginal costs. It will be? What is it gonna be? What is 2 times 0.01? Hello? 2.0.01.
Hello, okay, just 2 times 0.002.
Negative 0.002 x plus 2. And this is 0, right?
Yes.
As our marginal cost function. Okay? Right?
Yes, sir.
Marginal revenue. We need to find the revenue function again. We already have, revenue is equal to price times the output. Output is given by x. So the price function is negative 0.05 x plus 25, and all that's to be multiplied by x. And when you go ahead and multiply all this, you have negative.
0.5
you will have
x squared.
negative 0.05 x squared plus 25x. Derive this function now to find the marginal revenue.
So we'll have
negative
2 multiplied by 0.05. Just a minute.
It's 10%.
So we'll have negative 0.1x. Yeah, plus
25.
Yes.
That's marginal revenue function. The other question was find the marginal average costs function. So we need to find the average cost function. So this cost function to be divided by x, that will give us negative 0.001 x plus 2, right? You're following, right?
Yes, plus 200.
Plus 200 over x. Right. Average cost. Is it?
Yes.
And so we can rewrite this as negative 0.001 x plus 2 plus 200 x to the power negative 1, right?
Yeah.
And now this is the average cost function. We can differentiate it to find the marginal average cost. When we differentiate this, we'll have negative 0.001. This is a constant minus 200 x to the power negative 2, which will be negative 0.001 minus 200 to be divided by x squared, yeah?
Yeah.
Marginal average cost. This is the application of calculus. So these are some of the solutions that were worked, but obvious, these are quite similar stuff. You can easily go on again at your own time, just solve through, and you should be fine. Should be fine with that.
Okay, I'm kindly asking